All right, let's look together at number 1. It says consider the equation y equals x squared plus 3x minus 4. Our job is to determine whether the function has a maximum or a minimum value. Then we need to state that maximum or minimum value, and then find the domain and range of the function. So quite a few things to look at here. Let's start by just taking a look at that standard form quadratic equation. It says y equals x squared plus 3x minus 4. This is a trinomial. We have 3 terms, and let's look at that first term first. It says x squared, but this is our a term, and we should know that there's actually a coefficient of 1 kind of hiding here. This coefficient of 1 tells us a couple of important things. First of all, it does tell us that this parabola opens upwards. It also tells us how wide or how narrow this particular function is. Since the coefficient is 1, we know that this parabola is just as wide as or just as narrow as the parent function x squared. Let's skip the middle term for now and go look at the third term, which is our c term. Our c term's value is negative 4, and this tells us very specifically that the y-intercept for this particular function is located at 0, negative 4. We know that the x value is 0 because at the y-intercept x is always 0. Alright, now before I graph anything, I want to go ahead and think in my mind what a picture of this problem might look like. I know that it opens upwards, and I know that the y-intercept is located at negative 4. So just sketching a rough graph, or a rough image in my mind, I know that it's going to look something like this, which tells me that the vertex, or the turning point of the function, is going to be a minimum. I don't exactly know what the coordinates for that vertex are yet, but I know this will be the lowest point of the function because the parabola opens upward. Let's go ahead and take a moment to graph this on our calculator, and then we'll see how to solve this using some algebra. We're going to go to y equals on our calculator screen, and we're going to type in the standard form equation exactly as we see it. It'll be x squared plus 3x minus 4. And when you're ready, go ahead and hit graph. When we graph it, we can see it does in fact match what we had expected. We do have a parabola opening up, and our vertex is located in quadrant 3. This tells us right away that both our x and our y coordinates of our vertex are going to be negative values. We can see very clearly that the lowest portion of this particular parabola is located as a negative y value. So if we're looking at all of our answer choices here, there's quite a few that we can eliminate right away. Let's go ahead and start by eliminating choice C and choice B. They both imply that there's a maximum value for this function, which is not true. We know that there's a minimum value for this function. We can also go ahead and eliminate choice A because we can see very clearly from the graph that the minimum is not located at y equals 0. From that, we only have one reasonable answer choice, and that is choice D. But let's take a moment to see how we could solve this using a few little bits of information from our calculator and also doing some algebra. If we hit the trace button on our calculator, this allows our cursor to be interactive on our screen. Now that our cursor is tied to the function, we can go ahead and use the left and right arrows to take a look more specifically at that lower point. Now, this will just be an approximation, but if I move this cursor down to the lowest point, I can see very clearly that the ordered pair is somewhere around negative 1.5 and negative 6.25 on my graphing calculator. This is just an approximation, not an exact calculation, but it's clearly enough to answer this question correctly. Now, let's suppose that we didn't have the graphing calculator available to us. How can we go about finding this answer just the same? Well, we know a couple of things. We know that negative b over 2a is the ratio that gives us the x value of our particular vertex. So let's go ahead and fill in those values, and let's calculate the x value of our vertex exactly. It'll be negative 3 over 2 times 1. These values come from our standard form equation. The b value is this middle term, which has a coefficient of positive 3. We need the negative b. And then in the denominator, we have 2 times the a value, which we know is 1. To simplify this fraction, we have negative 3/2, which is negative 1.5. Now, this is our x value for our vertex, or our h value for our vertex. We also need to find the y value because this is where we'll find our minimum. To find the corresponding y value that goes with this x value, we need to evaluate our function at x equals negative 1.5. All right, I've gone ahead and written that in here. Let's take a look at how we could use just a standard calculator to do this calculation. Notice a couple of things first. Notice that I've used parentheses around my -1.5. This is to reduce the chance of a sign error using my calculator. We're going to replicate the exact same thing on our calculator screen. We'll open parentheses, -1.5, all squared, plus 3, then open parentheses, times -1.5, close parentheses, then subtract 4. Take care to make sure you're not using the negative sign accidentally when you mean to use the subtraction, and vice versa. When you hit enter, we should get our y value, which is -6 and 25/100ths, or -6 1/4. This is what we are expecting based on the graph, -6 and 25/100ths. This also corresponds with choice D, which we have already selected. Let's go ahead and analyze the domain and range of the function while we're here. Let's refer back to the graph on our graphing calculator. Looking first at the domain, remember that the domain are all of the allowed or possible inputs that we can put into the function. These are our x values. All of the x values that we could possibly think of, really any number at all, can be multiplied by itself or multiplied by 3. So our domain will be all real numbers. However, our output is a little bit more restricted. No matter what values we can come up with for x, our y values will never be smaller than -6.25 based on this graph. That is the minimum value of this function. If we look from the minimum going upward, we see that the range covers all values going up to positive infinity. So our range will be all the y values, starting at -6 1/4, going all the way up to positive infinity.